Okay, in the last tutorial we've talked about the series class. In this tutorial we'll talk about the DataFrame class, which is two-dimensional because it consists of rows and columns, and therefore it represents a complete table. Right? We will be introduced to multiple ways to create objects from the DataFrame class and work on these objects. In this demonstration, of course, we will do some data cleaning. We will handle some null values, some duplicate values, some wrong values. We will group the data by certain columns and apply some descriptive statistics. And finally, we will study the correlation between certain variables to see how they move in relation to each other. Now, the first step, as always, is to import the libraries that we are going to utilize in our project. In this case, we're going to use the Pandas library and the NumPy library, and we gave them these aliases to easily reference them later, which are PD and MP for NumPy. The first way, or out of the three ways that we are going to be introduced to today, the first way to create a data frame object is to pass a dictionary as an argument or input, where a key will be one column name and the corresponding value will be a whole list representing the column entries. So let's take a look at this example. Here we have, or we've created a dictionary named dict1, inside of which we have three key value pairs, where the first key is name, and the value is a complete list consisting of cat, dog, bird, and mouse. The second key value pair, we have the initial as the key and a complete list as a value consisting of C, D, B, M, right? Which are basically the initials of those elements. And finally, we have the weights key and the actual weights of these elements. Now, here we create a variable called pills_tf, and we set it equal to the name of the class, which is DataFrame, and between the parentheses we pass the dictionary as the input. So PD is the name of the library, DataFrame is the name of the class, and which we use to create the object, and we pass the whole dictionary. Now let's print out bits.df to see its shape. Let's make sure first that we run this cell, Control Enter, and the cell is run. All right, let's run this one. And as we can see, we have a table of 3 columns and 4 rows, starting from the index 0, ending at the index 3. So, as we can see here, the name is the column name, and the values in the list are the actual row values. So name, we have cat, dog, bird, and mouse. So here we have cat, dog, bird, and mouse. The second column is initial, and the list corresponding to that key is the row values C, D, B, and M. Third, we have the weights, and the weight as the column name and the actual weights as the row values. All right. Now, let us confirm that the type of this object we have created is actually a data frame. So we call the type method and type function, sorry, and as we can see, the type is data frame. It's also worth noting that each column in a data frame is actually a series object. Okay, so for example, let's create a variable called column1, and we set it equal to one series or one column from the data frame. How do we do that? By first referencing the data frame name, then we open square brackets, and then we specify the column of interest. So if we are interested in the column name, then we provide name as the key. The same way we access certain values in dictionaries. All right, now let's print this out. As we can see, what was returned, the series of 4 rows, cat, dog, bird, and mouse. Let's change this to initial. As we can see here, we have a different series. Now let's call the type function on this object, and as we can see, the type of this is a series. So a data frame is a collection or a list of series objects. Great. Now, the second way to create data frame objects is to call the pd.dataframe method or constructor and pass as arguments or inputs the following. First, a list of lists where each list represents a complete row in the data frame. As a second argument or input, we pass another list that contains the column names. So here we start by creating our list of lists, right? So we open this pair of square brackets here to indicate that we are going to create a list. Now inside, rather than placing single elements like 1, 5, 9, etc., we pass complete lists as these elements. So the first element is this list indicated by the pair of square brackets, comma, and then we pass the second list as the second element in the outer or the parent list, comma, third list, comma, fourth list. Okay, now each list of these will be considered one row in the resulting data frame. Second, we create a list of the column names. So in this case, the column names are name, initial, and weight in kilograms. Now we will move on and create our data frame object from these two lists here, the first list and the second list. So we say pits2, the name of the data frame, is equal to pd to data frame, and we pass list1 as the first argument, and as a second keyword argument, we pass the list of columns here, the name, the initial, and the weight. Now let's print this out to see its shape or form. Pits2, and as we can see, we have 4 rows total, where each row is actually one of the lists in list 1. As for the column names, we have name, initial, weight. That's because we passed the columns argument as the second input. Similarly, I will leave it to you to test or to check out the type of this object, which is supposed to be a data frame, and I will also leave it to you to extract certain columns to see that they are actually series objects. Okay, a third way is to simply to read the table from an external file. Okay, one common file extension or file format is CSV or comma separated values. Okay, so the first step is to specify the file path, and we've talked about the file path. It's simply the list of directories and subdirectories or folders or subfolders that we need to go through to get into a particular file. In this case, this file, dataframe underscore practice.ipymb, happened to be located along with the folder resources. Okay, so to get to that CSV file, we first need to enter the resources folder, and then from there we go to gradesdata.csv. Okay, so it's always relative. It's relative to the current working directory. Right, so where is gradesdata.csv in relation to dataframe underscore practice? In this case, it's one folder ahead in the resources folder, and then we get to the grades.csv. Now, use the read CSV function from Pandas to read the data and store it in a data frame. And in this is very simple. We create a variable called gradesdf, the name of our data frame. Then we reference the library, and we use a built-in function within the library called readCSV. And we pass the file path to that CSV file. and Pandas will automatically read the data and store it inside a data frame called grades.df. Right? So let's run this cell and see this data frame. As you can see, we have a data frame of 3 columns and 32 rows, starting from 0 all the way to 31 as the indices. Now, just to give you an idea, this simply is a table consisting of some grade data for some students in different subjects, right? So the first row is for student James in the subject of biology, and the grade was 98. The second is Susan, for Susan, subject of math, and 63 as the grade, and so on and so forth. Now, let's start referencing the different attributes within the data frame class to get some information about our data frame. Starting with the first one, what is the data type of each column? We can get this information by using the dtypes attribute, right? So let's go to a new cell here to have a cleaner output. Copy this attribute down here and see. As you can see, it basically returns a series object consisting of each column and the data type of that column. In this case, the student is the index, right? An object is the value at that row. And the reason why we get object as the data type for student and subject is because a string type is considered an object, right? Remember, we've said that everything in Python is an object, and string is a class from which we can create objects, right? So since we have strings, then the student column will be of object data type. Subject is the same, and for the grade, integer is the data type, which makes sense, right? By looking at the data frame. Okay, another attribute is the index, which prints out the data frame index. So let's print this out. Here we go. Again, it returns a range index object. To see the values extracted, we need to loop it through them in a way. So let's do that. For x in this, we print x. As you can see, the index list from 0 all the way to 31. Now, as we did the last time, if you want to get more information regarding a certain attribute or a method, you can always visit the official documentation of Pandas, right? Next, get the number of dimensions or axes in the data frame. By axes, we mean x, y, rows and columns. So in a table, we are expected to get how many dimensions? 2, rows and columns. Fourth, get the axes of the data frame. Remember, data frames are 2 dimensions, so there are 2 axes. So let's see what axes do we have. So we have the range index, which is basically the index of the data frame, all right? And we have the columns, student, subject, and grade. Okay, so the columns again are student, subject, and grade, and the rows are the rows start from 0 all the way to 32 with one steps each. Okay, next, get the name of the columns. All right, let's see the columns attribute for that. Here we go. It returns an index object consisting of the column names, student, subject, and grade. Okay. Next, get the shape of the data frame, number of rows and number of columns. Okay, shape. Here we go, 32 rows by 3 columns. So as you can see, we are using these attributes in order to get more information about the properties or the characteristics of our data frame. Next, get the number of elements in the data frame. We can use the size attribute for that. As we can see, 96, which is basically the number of rows multiplied by the number of columns. Finally, there is a special method called info, right? Which can be which we can use later, but let's use it now just to see the output we are going to get. Info. The info method basically gives us the attributes, the characteristics of our data frame. So for example, it tells us how many rows do we have, 32. It tells us how many columns we have, 3 columns. And then it lists all the columns along with the number of non-null values along with the data type of each column. So the first one, as we agreed, is object, the second is object, and the third is integer. So it basically gives you an overview of your data frame. Please keep this method in mind because, as you can see, it can be helpful. All right, now let's move to the harder part, which is data frame methods. All right, get the first 7 rows in the data frame using the function or the method tail. Okay, and for that we are going to use the grades underscore df throughout. So grades df set head, and we want only the first 7. So we say head 7. As you can see, we've gotten the first 7 rows, right? If we left it empty, then we will get the first 5 because the default value is 5 for the head method. How can we confirm that? Through the official documentation. Again. All right, next, get the last 4 rows in the series, in the data frame using the function tail. So we say grades df dot tail, right? Then we pass 4. Here we go. The last 4 are Laura, James, Michael, and Michelle. Okay, next. Get the student column from the data frame. What is the data type of the returned object? Okay, let's do that. We start by referencing the data frame object, which is grades underscore df, right? Next, we open up square brackets and we specify the column name, which is the student. Okay, let's store it in a variable called temp, for example. And then let's apply the type function to see the data type of this object. Here we go. It's a series. Get the grades column from the data frame and store it in a variable. What is the data type of the returned object? Now, as we saw before, the data type of grades is integer. Sorry. The data type is series. However, the data type of the values inside that series are integers. So let's do that for grades. Seems okay. The column name is not grade, it's grade. So it's also a series. Okay, awesome. Next, get the count of non-null values using the function count. Okay, so grades df dot count, because remember the count method basically returns the number of non-null values. So for the student column we have 32 non-null values. For subject we have 31 non-null, and for grade we have 32. So for subject there seems to be a null value. Now let's investigate that. Let's take a look at the original data frame. So for subject, biology, math, biology, art, keep moving. As we can see, at the index 21, the value is null or simply NaN. Okay, let's go back here and check which rows are duplicated, then count them up. Okay, let's create a variable called duplicates. Okay, and set it equal to the grades df dot the method duplicated. Right, the duplicated method simply returns the duplicated rows. Let's print it out. As we can see, false indicates that this row or entry is not a duplicate, whereas a true indicates that this is a duplicate value. So the value at index 17 seems to be a duplicate of some other values. Okay, now how can we get the number of true values in a series of Boolean values? Because remember, the returned object by the duplicated method is a series object, right? Now we can apply the sum method in order to get the number of true values. So we say sum. As we can see, it seems that we have two duplicate values. Okay, next, drop the duplicated rows, then count the rows to make sure they have been deleted. All right, let's say grades df is equal to grades df dot drop duplicates method. Okay, and then let's apply the count function to see how the data frame was affected with the duplicates removed. So we use the count method. There we go. So there were 31 for student, 30 for subject, and 31 for grade. Now the whole row or the whole duplicated rows were actually removed. Okay, so we were left with 30, 29, and 34 grade. Okay, great. Next, but before we go to the next part, you can confirm that there were duplicates by looking actually at the original data frame. So from looking here, we can see that these two rows are duplicated. So this one is duplicated from the one above, right? This one as well seems to be duplicated. So the row at index 25 were removed and the row at 17 were actually removed. So from 32 we move to 30. Let's go back and continue working. Right, does any of the columns contain null values? Use the as any function or method. Let's see. How can we do that? Using the is null method. So we say grades df dot is null, right? And we see the output here. So it basically retains a complete data frame with falses and trues under each column, indicating if there are null values or not. As we can see, we have falses across the board except a value here at line 21. This one is true. How can we confirm that from the original data frame? Let's look at the value at index 21 or the row at index 21. There we go. As we can see, David for student, NaN for the subject, and 94 as the grade. So there is actually a null value. All right. Let's go back and use the sum method in order to count the null values up. So we say sum. All right, so for student we have 0 nulls, for subject we have 1, and we have 0 for grade. So as you can see, the count method is very similar to the isNull method, right? You can use both in order to isolate if there are null values or not. Okay, let's isolate the grades subject, df, df here. All right. Again, at line 21, the value is none. Okay. Now, isolate the column and check its entries. Isolate the column and check its entries, which we did here, right? 2. Use the look attribute to isolate the grades of the student with the missing value. Okay, now, when it comes to isolating or extracting certain data points from a data frame, we need to use a special attribute, a very helpful attribute called the look attribute. So let's first go above, introduce ourselves to the look attribute, and then tap into it here in this section. Let's use this data frame as our example, okay, and see how we can extract certain data points. Let's first print it out to see its shape. Oh, sorry, let's go with bits df. There we go. Okay, so how can we get this data point right here, the initial D? What we do is we first reference the data frame. We open up square brackets and then, sorry, we reference the data frame. We use the look attribute, right? Then we open square brackets. Within the square brackets, we specify the row number or the index, and as a second input, we provide the column name, right? So it seems that D exists at the second row with index 1. So we say 1, comma, the initial column. As you can see, D were retrieved. Okay, now what if I wanted rows 1 and 2? In that case, we surround the row numbers with another pair of square brackets. So basically, we put them in a list, right? So we say 1 and, for example, 3. Here we go, a whole series were retrieved, right? Index 1, initial D. Index 3, initial M. Okay, what if we wanted multiple columns as well? So we wanted the initial and the name, for example, and the name. So we put these in a list as well. And as you can see, a complete data frame were retrieved for rows 1 and 3 with the columns name and initial. And here we have the data points. Okay, so this is the basic use of the look attribute. Also, within the square brackets of the look attribute, we can provide a particular condition to filter out the data frame and retrieve certain data points. So we can say, for example, pits df.look here, okay, and then specify a certain column, for example, the weights in kilograms, and obtain the values that, for example, are less than 5. Here is our condition. Okay. So again, look, we open square brackets and then we reference the column using the traditional way, right? And then we provide our condition less than 5. So we want to retrieve the rows where the weight value is less than 5. So let's see the output. As you can see, 3 were retrieved at index 0, at index 2, and at index 3. All of these values are actually less than 5. So we can use the look attribute or property in two ways, right? By first specifying the row number or the index number along with the column names to extract certain data points. Another way is to provide a condition to filter out the original data frame and retrieve certain rows or data points as well. Okay, so let's go back here. Let's go back here and use the look attribute to isolate the grades of the student with a missing value. Okay. Okay, so we have seen that the row at line 21 contains the null value, right? Now, how can you use the look attribute to isolate the grades of the student with the missing value, right? So if we looked at line or the value or row at index 21, we can see that the student name is David, okay? So now we can use that as a condition in the look attribute to retrieve the grades of David for all the subjects. How can we do that? By using the look attribute again. Grades df dot look open square brackets, and here we specify the column which is subject, or sorry, student, since we are interested in the grades of the student. So we say grades df of student all right, say is equal to the name of the student is David. Let's see, as we can see here, we have 3 rows for David, for biology, math, and null for the third value. Now, looking at again the original data frame, we can see that we have 3 subjects in total, right? We have biology, math, and art. So clearly the missing value here for this subject here is art, because we have biology, we have math, but we don't have any art subjects. So let's go to step 3. Can you check what the value of the null cell should have been? We've seen that it should have been art, right? If yes, fill that cell with the correct value using the look attribute, and then verify if it was filled correctly. Okay. So let's use the look attribute to isolate that value. How? By saying grades look. All right. What is the index number? It's 21, right? So 21. And we are interested in the column subject. All right. Now we say equal to, and then we provide the value art. So go to the row with index 21, column subject, and set it equal to art. Next, let's use the same statement, okay, to check if the subjects and grades of David are now filled correctly. As we can see now, the subject is art for David at line 21. Okay. All right, so this was part 1. We will continue working with the other methods in part 2.